Hey everybody, this is Larry. This is day 19 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. I'm gonna make it quick. The Yankees won, which is good. The Liberty lost, which is really sad for me. Just been watching too much sports, and they won really late, so that's why this video is a little bit late. But hopefully we just get. Let's just finish this. Let's do this. We got this. Let's do it. 1545. Find cave bit in nth binary string. Given two positive integers n and k, the binary string forms as follows. You have 0, and then you have... Okay, so then... Okay, we should... Oh, I was going to say that usually I would like to, look at some examples for intuition. But, and it's kind of confusing, but okay. So you have 0, and you're trying to find a k bit in it, right? And k could be really big. But of course, n is only up to 20 because every iteration only doubles plus 1, right? So, you have 1, so then it's double plus 1, so 2 to the n plus 1, but then, and then 7, and then 15, and so forth, right? So, yeah, powers of 2 minus 1, right? So, so I think this one, you just have to find out, it's almost like, it's kind of like a binary search, kind of, given the nth, you have to figure out, okay, well, the k, is it in the left side or on the right side, right? Or is it exactly in the middle? If it's exactly in the middle, then apparently it's a 1. And then once you do that, then you could recurse on the, this actually reminds me of a problem that we solved as a Leetcode hard recently, like maybe 2 weeks ago or something like this, right? But basically, there are only 3 cases. Actually, I was going to do some ASCII art again, but let me just bring up some my drawing board. Oh, find my pen. My drawing pen. Let me see, make sure I put it on screen, which I haven't. Which is why I have to make sure. All right. So yeah. So the idea here is that okay, now you have I don't know some. Let's look at it. Let me actually write this a little bit in a maybe ASCII art would have been okay. But anyway, so you have this is S4, right? So mind the poor handwriting, and maybe I just transcribe it incorrectly, but. Let me also double check. Right, and of course in this case this is the middle one, this is the left side, and this is the right side, right? And as we should know, the left side or the right side is just the left side reversed and inverted, right? So you could do some math there, but basically the relationship of reversing and the inverting part is easy, right? If it's 1 if it's 1, it's going to be 0. If it's 0, it's going to be 1. And in reversing, you have to clean up the indexing, but it should be fine. Basically, you're matching this number of this, or this digit of this digit, and so forth, right? And of course, you can come up with a formula for it. I would probably just guess off my head, just offset from the left side is probably the easiest, right? Or left side here, and obviously right side on the right side, right? And so if it's on the left side, then we know that it's going to be S3, right? Because things on the left just don't change. And then if it's on the right side, then you know it's going to be some function of S3, that reverse function that we talked about, right? Of like inverting and reversing. So, but this of course requires us to get to S3, and that's really the idea about this. And you can think about this kind of like divide and conquer. That's the word. I think I said binary search, but I didn't even mean it like that. I think divide and conquer is the way to think about it, in that you just divide it into a smaller, simpler subproblem, right? So then, let's see, right? So let's start. So n, right? Yeah. So, all right. So, how do I want to write this? I'm just gonna write out without true. Just we can fix this later because I haven't really thought it all the way through yet, honestly. But yeah. So given n iterations, it's going to be 2 to the n number of 2 to the n minus 1. That's it. Number of the total string, right? So maybe L is equal to, I don't know why I left in the comment, is equal to 2 to the n minus 1, right? And then basically the left side is going to be so L over 2, the left side, I'm trying to think just to make sure, because this has length 7, so that means that index 7 would be, this is index 7 actually. Index 7 would be on the left side, right? So yeah, so if k is less than or equal to L over 2, then this is on the left side. If it is sorry friends, on the left side, and then yeah. Oh yeah, maybe I'll just do it recursively. That's what I meant to do. That's why I said some problems. But yeah, maybe I'll have a solve for some n and k, right? And then here, and on the left side, then we can just return solve of n minus 1 k, right? Because on the left side, it's going to be the same as the s sub n minus 1. Else, if k is equal to L over, is this right? Maybe I got this wrong. So L is going to be 15 for 4. And so then this gives you actually 7, not 8. Oh, okay. Then we just return 1. Else, then it's on the right side. And basically you get, I don't know, D is equal to self n minus 1. But it's no longer K, right? Because we're trying to get the offset from the n instead. So you have to flip it, which is going to be L minus K plus 1, I want to say, right? Yeah. Because if K is the last one, if it's 14, then it is going to be 0. Yeah, I think this is right. And then we return 1 minus D. The 1 minus D just inverted. You could also write in different ways, right? Because if you have 0, it will give you a 1. If you have a 1, it will give you 0. And that's pretty much it, of course, except for that we have to do the base case. So if n is equal to 1, then we return 0. And I think that's it, really. Well, technically, I mean, this isn't a base case, but it is part of it. And then now we just have to write it this way. And you didn't even need a helper function. You could just call itself probably, but I like to separate it out only because in case I want to change it later, then I can, well, have that power. Apparently I have some indexing issue. Is K, why would I return 1 on? Dun dun dun. Well, Oh, this is 0th index, or first index. I thought that was the first thing I checked, but I thought I get confused. It's too late in the day. Oh, and we have to return a string. Why do we have to return a string? Is the bit okay? Fine. I mean, we have the technology, but I don't know why we're using that technology. Okay. So that looks okay. I mean, but for this problem, especially, you're just trying to find k and the n. We can actually not brute force, but we know what the first. Well, they tell you what the example is, so we can just plug it in. Maybe, oops, and then make sure that we at least get a good amount of them correct before submitting. Okay, that looks good though. So let's give a quick submit. Oh no! And apparently I did it correctly twice previously, but not today. I mean, if I have to guess, it's probably this thing, honestly. But okay, so we have 3, we have 7. 1, 2, 3, 4, 5. Why do I return a 0? Well, I mean, it's easy to debug, kind of. Or like it's easy to get a visualization out by just looking at every possibility. Oh, why is it 37? This UI is so bad. 0111000 for some reason. Huh. Alright, we can run this through too though, right? So 3, we have 37 or 36 because we subtract by 1. Oh. No, I mean, we did this okay next. Maybe I just did something wrong. Okay, so yeah, okay, yeah. So we have 36. This goes to 2 to the third is 8, so minus 1 is 7. That should be right. So 7, and we have 6. This is clearly, yeah, on the right side. So then now it solves. Oh, well, yeah. And actually, I'm a little bit tired. I'm a little bit lazy. So we can actually just print this out, right? So let's do it. Yeah, that looks okay. I just want to see where it goes. So 36 to 22, is that right? No, the 22 is not right. Oh, I'm dumb. Oh my, huh? I meant this. Okay, Larry. Silly rabbit. Alright, let's double check that though. Yeah, okay, fine. Sorry, it's about 1 a.m. here and I'm being sloppy. Yeah, let's double check the example, I suppose. Let's give it a submit. And okay, we're good. Apparently we're very fast, but I think there's just a bug or something weird because that doesn't make sense. What did I do in the past? Why does this take 2 seconds? Oh, apparently you could just generate it and then do it because it's less than 1 million. I guess I tried that after doing the divide and conquer way. Yeah, they're mostly the same. But today I even checked the indexing, but I did it in my head and I forgot the params because I'm a beginner apparently. But yeah. But so what's the complexity here, right? Well, it is going to be linear in the size of the input, keeping in mind that the size of the input is the number of bits, and the number of bits is just the number of bits to represent the number k, right? And for each k, we divide it by 2 pretty much every time, right? So, yeah, that's all I have for this one. Let me know what you think. Thanks for watching, and yeah. I'm tired today. My apologies. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.